dissolution test. Dissolution test is another test which is which is official in IP. In dissolution test, what you determine is you determine the percentage release of the dosage form from the dosage form. How much amount of drug is been getting released from that dosage form. Okay, that is what you determine. This dissolution test also mimics the condition that are happening inside the stomach. So what you do is, so it is an in vitro test, okay, but it gives you an idea how much drug is getting dissolved. If you remember, one of the differences that I told you about solubility and dissolution is dissolution is with respect to something. It may be with respect to time, it may be with respect to temperature, it may be respect to pH, it is with respect to something. Okay. So in this case, dissolution is always with respect to time. कितने टाइम में कितना ड्रग is getting released from the dosage form is determined by your dissolution test. Have you understood? In how much time, how much drug is getting released from a dosage form inside the stomach. Okay, we are just trying to predict it. Okay, with the help of the dissolution test. Now you will say, sir, we are already doing disintegration test. Okay, so don't you, the disintegration test also we are doing for this purpose also, this purpose only, in order to determine whether the drug is getting released or not. Okay, but there is a difference between dissolution and disintegration. Disintegration test doesn't give you an assurance. Okay, there is no assurance that is that you get from the disintegration test. A tablet may disintegrate, okay, into small particles. So it is getting disintegrated into small particles, but there is no guarantee that the drug is getting released from these particles. Okay, one thing is sure, if the tablet is not going to disintegrate, okay, then definitely it is not going to get dissolved. Okay, for dissolution, disintegration, okay, is your first step. After disintegration, so tablets are going to get disintegrated and then it is going to get dissolved. So disintegration is your first step that should happen, except for some dosage form where there are some special dosage form where the tablet remains intact and the drug is getting released. Okay, you have such dosage form also, but these are special dosage form. Okay, we are not going to carry out dissolution for test for, we don't carry out disintegration test, we don't carry out dissolution test for these dosage form. I am talking about the normal uncoated tablet. Okay, 70 to 80% of the tablet, okay, are in this category, which are uncoated compressed tablet. Okay, for them the tablet first has to disintegrate and then it is going to get dissolved. But after doing disintegration test, okay, there is no guarantee that the drug is going to get released. Then the question arises, ये क्यों करना है? और आपको dissolution test ही करना है तो disintegration test ही क्यों करें? Okay, please remember, disintegration test is an IPQC test. While the production is going on, you are doing the disintegration test. Dissolution test may take some time. Dissolution test may take near about 2 to 3 hours to complete. Okay, whereas disintegration test takes only 15 to 20 minutes to complete. Okay, so when the production is going on, you do disintegration test in order to determine whether the tablet is going to pass or fail in the dissolution test. Though there is no guarantee, but at least आप predict तो कर सकते हैं कि नहीं बाबा disintegration नहीं हो रहा, इसका मतलब dissolution भी तो fail होने वाला है, या फिर अरे disintegration हो रहा है तो no problem, it is going to get dissolved further. Okay, that much prediction you can do from the disintegration test. Okay, coming back, so disintegration test doesn't give you an assurance, okay, that the particles will release the drug in the solution in an appropriate rate. Please remember, appropriate rate is also very important. In that given time, you want the drug to act. Okay, just take an sublingual tablet. You want the drug to get released within 3 minutes. Okay, so that particular time the drug should get released. Okay, That's why we carry out the dissolution test. Okay, understood till there? Moving ahead. Now, how do you carry out the dissolution test? In order to carry out dissolution test, let us first study about the dissolution apparatus. How the dissolution apparatus is. Okay. Now, the dissolution apparatus consists of a cylindrical vessel flask. Okay, this is the flask that it consists of. It is a cylindrical vessel. Okay, so this is a cylindrical vessel. It is made up of borosilicate glass. So it is made up of glass, or it can be made up of plastic also. Suitable transparent material plastic also can be used. And what it is having? It is having a hemispherical bottom. So this is the hemispherical bottom that is there to this cylindrical vessel, okay, or this flask. The capacity to hold the dissolution medium is near about 1000 ml. The medium that you put inside is known as dissolution medium. Okay, so this is the medium that is known as dissolution medium, which you put inside this flask. So you put this dissolution medium inside the flask. How is the inner diameter? The inner diameter of the flask is 98 to 106 mm. Okay, and this flask is maintained at 37 plus or minus 2 degrees Celsius, because this flask is placed in an water bath. This water bath is heated, okay, with the heating coils. So you have heating coils over here. These heating coils are going to heat this water bath. You have the dissolution medium that is put over here. What is the dissolution medium that you use? You can use simulated gastric fluid. Okay, you can use simulated intestinal fluids. You can use buffer solutions. Okay, you can use acidic solution. You can use alkaline solutions, depending upon the whatever your test is, and depending upon whatever your drug is, depending upon your tablet. You are going to select different you can select different mediums, and you can put into this. Okay, moving ahead, this vessel has flanged upper rim. So this rim, if you can see over here, okay, this rim is nothing but a flanged upper rim. Okay, this rim, you have this kind of a rim so that it can be fitted with a lid. So this is the lid. Okay, with the help of this, the lid is placed onto this flanged upper rim, okay, of this vessel, and it has number of openings. Okay, one of which is in the center. So this is the central opening. Okay, in through this central opening, what do you fit? You fit the stirring element. So through this central opening, you place the stirring element inside this cylindrical vessel or inside this flask. Right? Got it? Another opening is there for. So this is another opening which it is having. So this is the opening that it is having. This is used for removal of sample. So from here, the sample is going to get, removed. Okay, which sample, that I will tell you further, what sample you have to remove. There may be one more opening in order to put your temperature probe inside it, which is going to, so one more opening would be there, which is going to measure the temperature that is present inside this cylindrical vessel. Okay, right. Now, this dissolution apparatus is of two types. Okay, it is known as dissolution apparatus 1, or known as IP apparatus 1 and IP apparatus 2, or USP dissolution apparatus 1 and USP dissolution apparatus 2. What is the difference between these two apparatus? What is the difference between apparatus 1 and apparatus 2? Apparatus 1, as per IP, okay, as per IP, apparatus 1 consists of paddle kind of an arrangement. Okay, whereas, so it is having a paddle kind of an, which is attached to this drive shaft. So this is the drive shaft. Okay, this is the drive shaft. To this drive shaft, this paddle type assembly is being attached to it. Whereas in IP apparatus 2, this paddle type, okay, is replaced. This paddle is replaced with a basket. Okay, so that is the difference between apparatus 1 and apparatus 2. In apparatus 1, IP apparatus 1, you have paddle type assembly. In IP apparatus 2, you have basket type assembly. Please remember, as per USP, USP apparatus 2 consists of paddle, whereas USP apparatus 1 consists of basket type assembly. It is exactly the opposite. IP apparatus 1 is equal to USP dissolution apparatus 2, and IP dissolution apparatus 2 is similar to USP dissolution apparatus 1. This is only the major change, okay, in USP and IP. Okay, that is apparatus 1 is apparatus 2 over here, and apparatus 2 is apparatus 1 over there. Okay, so that is the only change that you have in the assembly. Okay, got it? Once again to repeat, it consists of a cylindrical vessel made up of glass or made up of plastic. 1000 ml can be the capacity of it. Okay, the inner radius is 98 to 106 mm. The temperature inside is maintained at 37 plus or minus 2 degrees Celsius, because that is the temperature inside your body. This temperature is maintained with the help of the water bath. This cylindrical vessel is put inside the water bath. Okay, it consists of a flange rim. This flange rim helps to place the lid onto this vessel, okay, or flask. This lid has number of openings. One of the central, through the central opening, what you place is, you place the drive shaft is placed through the central opening. Other opening is there in order to remove this sample, and there is one more opening through which you can put your temperature probe inside to check the temperature of this medium. You have two type of apparatus. You have apparatus 1, which is paddle type as per IP, and apparatus 2, which is basket type. Let us move further. Okay. Now in dissolution apparatus 1, so this is paddle type assembly. Okay, so this paddle can be removed, and instead of this paddle, you can place this basket. You can attach this basket. Okay, so this in paddle type 1, what happens is the tablet goes and is placed over here. Okay, I'm sorry. If you see, the sample for which the tablet for which you have to carry out dissolution test is placed inside the vessel, whereas in case of basket assembly, the tablet is placed over here. So that is the difference. So in paddle type assembly, it is placed inside the vehicle, inside the vessel, whereas in case of basket type assembly in apparatus 2, it is placed inside the tablet, inside the basket, जिसका आपको dissolution check करना है. Okay, got it? Right. So the dose, that is the tablet, is allowed to sink to the bottom of the flask for stirring. The dosage form can be tablet. For capsules also, the same assembly is been, the same apparatus has been used to carry out the dissolution test. Whereas if you take dissolution apparatus 2, that is the basket method, it consists of a small wire mesh basket. Okay, so this is a small wire mesh basket which is attached to the bottom of the shaft. So this is the shaft. To this shaft, you just have to remove this paddle and you have to attach the basket. Okay, so the same equipment you can use for basket also, and you can use for your paddle type also, right? So the single basket is placed in a small wire basket, okay, which is attached to the bottom of the shaft and connected to the variable speed motor. Okay, what does the speed motor do is, this speed motor rotate this shaft. Okay, so this shaft is rotated, drive shaft is rotated with the help of the speed motor. So this drive shaft is attached on the top to the speed motor, which is going to rotate it at a constant speed. Right? The speed can be adjusted, the speed with which this paddle is going to rotate or this basket is going to rotate. So once the drive shaft is rotating, okay, so as the drive shaft starts rotating, what is going to happen? This paddle is also going to rotate. Okay, and if the paddle rotates, the medium inside the vessel is also going to get stirred. So stirring is carried out with the help of this paddle. In the similar manner, okay, if you place the tablet over here, as this basket rotates, which is attached to the shaft, okay, that is further attached to the shaft. As this shaft rotates, this basket is also rotating, and inside it the tablet is also going to rotate. The medium is going to flow inside and the medium is going to flow outside of it. Okay. So finally you have the vessel over here, and inside this vessel you are going to get the dissolved particles, right? Let us move further. I'm not going to go into the details of these dimensions because it is unnecessarily going to confuse you. Remember, in your monograph, under the drug section, everything would be given. What should be the speed of the motor for that particular tablet? What should be the speed of the motor? What should be at which the drive shaft should be rotating? Okay. What should be the RPM that would be given? What should be the temperature that should be maintained would be given. What is the medium that is to be used will be given. Okay. And sometimes the assay procedure in order to find out the amount of drug that is there coming in the medium, okay, that also would be given. Moving ahead. So all these are the variables that would be given. The dissolution medium that is to be required, that is to be put. So you have this semi-hemispherical vessel. Inside this semi-hemispherical vessel, you are going to put this dissolution medium. So that would be given. How much volume you have to add? Usually, if nothing has been given, usually 900 ml, okay, of medium is been used. Okay, if it is given, then fine. If it is not given, then 900 ml you are going to use. Which type of apparatus is to be used? That is also many a times given. For example, whether you have to use apparatus 1 or you have to use apparatus 2. That is also given inside in the monograph. Okay, so that is also given in the monograph. What should be the RPM of the shaft? So you have a shaft over here. At what RPM this should be rotating? That is also going to be given. The time limit of the test will also be given, and the assay procedure would also be given in the monograph. And the test tolerance is expressed as what? Percentage of the labeled amount of the drug, like we do for content uniformity. In content uniformity also what you find out? The percentage of drug that is getting released from the dosage form. Here also you find out the percentage of the drug that is getting released from the dosage form. Okay. The only difference over there, in that you are going to dissolve your drug. You can break your drug, you can dissolve your drug, and you are going to and then you are going to evaluate the procedure, right? And that is not with respect to time. Dissolution test is with respect to time. Okay, that is the main two difference between the content uniformity test and your dissolution test. Okay, moving ahead, let us see the working of this. Let us see the video how you carry out the dissolution test. So what you do is you place this medium, dissolution medium. This is paddle tab assembly. You adjust the temperature. You place the tablet. You start the machine, and now you are taking the sample. This sample has been taken. After some time, when you take the sample, then I'll just tell you what is the sync condition a little bit later. And then you perform the analysis. Okay, got it? Now, what the person, if you had seen the test properly, okay, what he had done in between was he removed the sample, and at the same time he put in some sample inside it. So when he was removing the sample, okay, when he was removing the sample from this, what he was removing the dissolved particles. Okay, so you remove the dissolved particles from the. Just a second, I'll just explain you. So you have this what you call that vessel. Inside this vessel you have put the tablet and you have started the operation. So what is going to happen after some time is, after some time the drug is going to get released from this tablet. Okay, so drug is going to get released from the tablet. Say after 10 minutes, now you remove the first sample. मैंने आपको बताया यहाँ पे सैम्पलिंग प्रोब है. सो यू रिमूव द सैंपल, यू हैव अ सैम्पलिंग होल ओवर हियर टू द lid. From this hole you remove the sample, some content of the sample, right? Let's just imagine that you have removed 5 ml of the sample from it. Okay, so 5 ml of the sample has been removed from it. Now what you are going to do is, after removing 5 ml of the sample which contains medium plus the dissolved drug, so it contains medium plus the dissolved drug. Now you are removing the medium plus the dissolved drug has been removed. What you now do is, you again put 5 ml of the medium, only the medium inside it, right? So आपने 5 ml निकाल लिया था मीडियम, आपने 5 ml वापस उसमें मीडियम डाल दिया. This is known as maintaining of sink condition. This is how you maintain the sink condition. At any given moment of time, supposing you keep on removing this 5 ml, then what is going to happen? This medium is going to go down from 900 ml. If you remove 10 times the sample, it is going to become 850 ml, isn't it? So the amount of this this is going to get reduced. Dissolution medium is going to get reduced. That doesn't happen inside the stomach. Does it happen? No. At every given moment of time, the amount of the stomach fluid is going to remain constant. So we are keeping that dissolution medium as constant. This is known as sink condition. Why it is known as sink condition? Because if you see your sink, the amount of water that is present inside the sink is always remaining constant. Okay, even if you flush off everything, still it is going to have some water. The required amount of water is always going to be remaining over there. So that is maintaining of sink condition. In the similar manner, you also maintain the sink condition. Okay. So once again, what you do is, in order to carry out the procedure, you take the tablet, you put it inside the vessel, okay, or inside the basket. You start your machine. Once you start your machine, okay, after some time, the drug, we are assuming that the drug is getting released from it. You are removing the sample and you are evaluating it. You are carrying out the assay and you are determining how much amount of drug has been released from it. Clear? Got it? So within 10 minutes, how much drug has been released? Within 20 minutes, how much drug has been released? Within 30 minutes, how much drug has been released? And within 1 hour, how much drug has been released? And within the specified limit, as I told you, the time limit is given over there. In the specified limit, how much drug has been released? In the specified time, how much drug has been released? That you find out. Got it? Okay. Let us move further now. Now, what are the limits and what are the standards that you have to find out? Now, the test is carried out at 3 stages. The first stage is known as S1 stage. In S1 stage, what you do is, you take 6 units. It means you take 6 tablets. And these 6 tablets are put inside the dissolution apparatus. So once you have a water bath, one water bath can contain number of dissolution apparatus. Okay, we have 3 different apparatus. Okay, machines. Okay, one consists of 3 vessels, one consists of 6 vessels. Okay, and one consists of 8 vessels. So you can have 6 vessels, 8 vessels. Okay, you can have 3 vessels, or you can have also 1 vessel also. So depending upon how much vessels you have, you are going to put but the test is carried out for the first test is carried out for this 6 tablets. So you put 6 tablets inside the in one vessel. You are going to, in one flask, you are going to put only 1 tablet. Okay. Now what is the test? In S1 level, the number of tablets that you are putting is 6. Now what is the acceptance criteria? Acceptance criteria is, within the specified time, whatever limit has been given, each unit, means each tablet that is put over here, okay, contains not less than D. D is nothing but the label claim. Okay, D is the amount of dissolved active ingredient. Okay, so the amount of active ingredient plus 5% extra should be the released percentage. Just for an example, now your tablet is having 100 milligram of the drug. Okay, so within specified time, say 30 minutes is the specified time. Let us assume. So after 30 minutes, all these 6 tablets should release the drug, okay, of how much? Of 105 milligram. Okay, that much should be the release of drug, right? And how this is been obtained? Okay, this is obtained because of your overages that you are going to add into it. So each unit contains not less than this much amount of drug. D is nothing but the amount of dissolved active ingredient, okay, expressed in percentage of the label content, okay, and this 5% is nothing but the percentage of the label content. So whatever is your label content, so 100 अगर है तो हर एक यूनिट ने 105 milligram should be released from that drug. If this does not happen, okay, then what? Then you have to go to stage 2. In stage 2, what you are going to do now is, in stage 2, you are going to take further 6 tablets. So the total tablet now has become 12. बराबर है? So S1 and S2 मिला के आपके 12 tablets हो गए. So what should be the drug content of these 12 tablets? Okay, it should be average of this. So supposing one is 105, the second one is 99, the third one is 96, okay, the fourth one is 110, the fifth one is 85, okay. So this इसका आप average निकालोगे. So you'll take the average of these 12 tablets. So average of the 12 units is equal to the label content. What is the label content? Label content is 100 milligram, I told you. Okay, should be equal to or greater than D. So it should be 100 or greater than that. But not a single unit should be less than 15, D minus 15%. Not a single unit should be less than D minus 15. If something is having 84, then it fails. If this happens, if it is not satisfying this condition also, then what you are going to do is, now you are going to enter the stage 3. In stage 3, what you are going to do is, you are going to take 12 new tablets. So पहले आपने 6 लिया, इसमें कुछ problem आ गया आपको. Okay, each unit was not D plus 5. There were some units which were only D, or it was D minus 5. Some units were there. So you went to stage 2. In stage 2, you again did 6 tablets. So this first 6 tablets and second 6 tablets, now you calculate the average of S1 plus S2. But here also it has failed because some of the tablets were less than, okay, or greater than D. Some tablets were less than D, okay, and hence the tablet has failed the test. So now you enter the stage 3. In stage 3, now you are going to take 24 tablets, okay, and average of these 24 tablets, what result you should get? That it should be equal or greater than D now. At least in सबका बार 24 का average should be greater than or equal to D, and not more than 2 units. Here what we have allowed was no unit should was less than D minus 50. But here how much we are allowing? Not more than 2 units are less than D minus 50. And you have to remember, no unit is less than D minus 25%. Okay, so if the label claim is 100 milligram and any given moment of time you find that one tablet is having content uniformity of the dissolution of it has dissolved only 75 milligram, okay, there and there the test is going to fail. Understood? Okay, please go through this, try to understand it. If you have problem, read this example also which I have given of paracetamol. Okay, try to read this example. If still you have problem after reading the example also, please do ask me. If you have understood everything, need not write anything in the chat box. If you have not understood, please write down in the chat box. Please go through this. D is nothing but the label percentage.
Sir, I have a doubt.
Yes, please.
Sir, the number of tablets which have been taken, that is 6 tablets. So, sir, is the each tablet is taken in different apparatus, or all the 6 tablets are dissolved in the same apparatus?
No, in different flask. So if your unit, if your apparatus is having 8 flasks, in 6 flasks you are going to put 6 tablets. So each flask is going to have only 1 tablet. So this is your flask. Okay. In this flask you are going to just put 1 tablet over here. Got it? In the other flask you are going to put other tablet. You have a second flask. In the second flask you are going to put the second tablet. Right? Then only you are going to get this results. Na? Okay. And from each flask you are going to withdraw the sample and you are going to do the assay. That's why I said this is going to consume time, and hence it is not IPQC, but it is a QC process. Got it? Who was speaking with me?
Yes, sir.
Who was speaking with me now?
Sir, Ved.
Ved, sir.
Huh? Ved. Okay. Ved, have you understood? Okay. Any other problem? If anybody has not understood, please. Okay. Nobody has written anything, means I assume that you have understood it. Let us move further with the example. Let us take the example of paracetamol tablet. Okay. Let us say the quantity of active ingredient is 500 milligram. So that is the quantity of active ingredient. So in the first stage, in stage 1, everybody should have, okay, each tablet should have active ingredient, which is, I forgot to write down the full sentence. Okay. Each tablet should have active ingredient, that is 525 milligram. Each tablet should have, all the 6 tablets that you are taking should have the active ingredient to be 525 milligram. If this happens, leave it. The test ends over there only. If not, then you go to stage 2. In stage 2, what you are going to do now is, you are going to take the earlier 6 readings you have. You are now going to take the readings of further 6. Okay. So the amount of total active ingredient now should be 600 milligram. हर एक का 500 मिलीग्राम है. So सबका मिला के total active ingredient 12 tablets का मिला के कितना होना चाहिए? 600 milligram. So it comes to 500 milligram each. And no unit should be less than 425 milligram. Okay. No unit should be less than this. Further, what we are doing is, now if that happens, if it is not satisfying this condition, we go to stage 3. Here we take 24 tablets. It should contain total active ingredients as 12,000 milligram. Okay. So that each tablet is going to have 500 milligrams, and not more than 2 units should be less than 425 milligrams. Okay. And no unit should be less than 375 milligram. So this is going to satisfy this condition also, and it will be satisfying this condition also. If it is either passing in stage 1, the test passes. If it passes stage 2, then also the test passes. If it passes stage 3, then also the test passes. Okay.